Alright, so if we look at the first one, we could rearrange the top to look like the bottom, but x squared minus 1 is not really something we can deal with because the derivative is 2x, and it doesn't come up on the SI table on the reference booklet. So we could do partial fractions, no problem. It is a square on the numerator and a square on the denominator, so we need the a by itself, and then if we factorize the bottom, it's difference of two squares, so we need a b on x minus 1 and a c on x plus 1. All right, so to find the a, b, and the c, we already know the a has to be the coefficient of the x squared, which is 1. For the b, we can use the cover-up system and cover up x minus 1 and sub in 1. So we've got x plus 1 on the denominator, which is 2, and we've got a 2 on the top, so we get a 1 again. And C, we can cover up x plus 1 and sub in negative 1, and that will give us a negative 1. All right, so if we do the integral now, we have the integral of 1 dx plus 1 on x minus 1 dx minus 1 on x plus 1 dx. So we'll get an x, we'll get a log x minus 1, and we'll get a log x plus 1 plus c. There we go. So that is A. If we look at B, we will end up with, again, so we've got x squared plus 1. If we factorize the denominator, we've got x times x minus 1. So again, we've got a square on a square, so we need the A, the B on x, and the C on x minus 1. So again, the A would be the coefficient of x squared, which is 1. The B, using cover up and subbing in 0, would be negative 1. And the C, using cover up x minus 1 and subbing in 1, would give us 2. So here we've got the integral of 1 dx minus, because b is minus, dx on x, and c is 2. So we've got dx on x minus 1. So we've got x minus log of x plus 2 log of x minus 1 plus c. All right, so let's have a look at c. So for c, we've got this cubic, and it's a cube on a cube, so this time we're going to get a again. The b would be if I factorize the bottom. I've got x and then x squared plus 1. I'll do it properly for you. Alright, so let's go again. So we've got x cubed plus 1 on the numerator, and if I factorize, I've got x squared plus 1. So cube on cube, so I need the a, I need the b on the x, and then my next denominator is a squared on the bottom, so I need cx plus d. I need linear on top. Okay, so again, the a will be the coefficient of x cubed, which is 1. The b, I can use a cover-up of x and sub in 0, and I'll get 1. I can't do so much with c and d, so let's have a look at the coefficients. Let's have a look at the coefficient of x squared. So if you can't see it very well, it's always good to write it out and check it out. So if you were writing it out, you would have to multiply the b by the x squared plus 1, and you've got cx plus d, and you're multiplying that by the x. So a coefficient of x squared, you would have 0 on the left, and x squared, we would get a b and a c. So b plus c. So you're kind of looking at, where am I getting x squared? I'm getting b times that. I'm getting cx times that one. So I'm getting b plus c. B is 1, so that will give us c is negative 1. All right, let's look at the coefficient of x as well. So coefficient of x on the left is 0. There's none on the left. For x, we've got an a here, and no b's, but we've also got this d here. So we've got a plus d, and we already know a is 1, so d is -1. All right, so putting that into the integral, then we would have a b on x, b is 1, so just that one. Now here we've got minus, so we've got a 2, so a cx plus d here, so I should do it properly. So we've got plus, and we've got -x, -1 on x squared plus 1 dx. So what I can firstly do is make them positive and make this negative. And then the other thing is I want a 2x. So what I can also do is put a half out the front and times everything by 2. So I get that. So this one will be x, this will be log of x. The pen is not going to work for me for some reason. Log x. Alright, and then if I break this one up, I've got minus a half. Let's break it up. 2x, x squared plus 1 dx. And then let's put minus a half times 2, so just minus 1 of 1 on x squared plus 1 dx. That gives us a nice easy integral. So we've got 1 minus a half, and we've now got the log of x squared plus 1 minus, and we've got an inverse tan of x here. And don't forget the plus c. Alright, so that leaves us with D, E, and F. So let's have a look at D. Let's clear all that. So for D, let's have a look. We have to factorise the bottom. So we've got x minus 2, x minus 3 will give us positive 6, yep, and a minus 5x. Again, you've got x squared on an x squared, so I need the a, then I can just have the b on x minus 2 and the c on x minus 3, and the a will be the coefficient of x squared, which is 1. B will use the cover-up of x minus 2 and sub in 2. C will use the cover-up of x minus 3 and sub in 3. So we should get now, that'll be 1 dx. B is minus 4. And C is 9. So we get x minus 4 log of x minus 2 plus 9 log of x minus 3 plus c. Okay, so not too bad. E, if we look at E, again we need to factorise. So let's factorise. We get x plus 1. So here we've got a cube on a square, a cube on a square. So not only do we need a constant, we need like an ax. So we've got an ax, we've got a constant. Then we can have the c on x and the d on. So this is a really top-heavy equation, improper fraction here. All right, so easy again. A, the coefficient of x cubed, is going to be give us a, so that'll be 1. We can cover up the x to find c and sub in 0 and you get 5. And we can cover up the x plus 1 and sub in -1 to get d. But then we have to look at something to find our b and perhaps the coefficient of x squared. If we were to expand, as in when we're looking at, so times everything by this denominator, so we're just looking at the top. So when I look at the coefficient of x squared, on the left-hand side I've got nothing. And on the right-hand side I'm going to end up getting a, because you're going to have a times ax times x times 1, so that'll be a. And you'll also get b, because you're going to have b times x there. but you can't get any of the others. So it's just going to be A plus B, and we know A is 1, so B would have to be -1. All right. So again, if you struggle to get the coefficient, then you want to write it out. You want to start multiplying. So you're going to get x squared, x plus 1 there, and you're going to get B. Oops, I forgot to put the x, etc. And then you can easily see where you're getting it. So for example, that x squared, coefficient of x squared, you're going ax squared times 1, and this would be b times x to get the x squareds. All right, but if you can do it without writing it out, that's fine as well. So now we've got integral of 1x dx. What was b? B is -1, so we've got -1 dx. C is 5, so we've got 5 dx on x, and d was -4. So again, just nice logs and easy integrals. 5 log of x minus 4 log of x plus 1 plus c. Pen is going to stop working soon. Alrighty, so that is, what was that? That's E. Alright, good. So F, let's have a look at F. So for F again, we need to factorize the denominator into its quadratic part. So we've got x to the 4, and we've got x minus 1, x minus 2. Alright, so it's the power of 4 on x squared. So not only do we need the constant and the x, we need an x squared now. So we've got an x squared, an x, a constant, and then we can have our fraction ones, d and e. Alright, so looking at that, we know that a will be the coefficient of x to the 4, which is 1. D, we can do a cover-up, so we get D and E using the cover-up method. And to get B and C, we need to look at coefficients. So again, if you need to expand out to look at the coefficients, for example, you'll get ax squared, and you're multiplying by x minus 1, x minus 2. You've got bx, x minus 1, x minus 2. You've got d, x minus 1 cancels, so x minus 2. And you've got e, x minus 1, x minus 2 cancels. So looking at the coefficient of, and you can pick different things. So let's say x cubed. If I was looking for x cubed, where will I get x cubed from? There's two ways to get it from this first term. I could say ax squared times x times minus 2. Or ax squared times x times -1. Sorry about that. So I've either got, of course it's 0 on the left, so I've got 0 equals, so I've got a -2a, yeah, a -a, and the b will also give me an x cubed, but none of the d's or e's would. So here I've got 3a equals b, and a is 1, so b must be 3. So now we've got b. Let's look at the constants maybe. So looking at the constants, this term can't give us a constant. The b has an x, so it can't give us a constant. We've got -2, and it's 0 on the left, I should have said. So -2d and a -e. That will also give us a constant. We know d is -1, so this will be a 2. So e is going to be 2. Is that what I was looking for? No. What happened to my c? I lost my c. That's the problem. I lost my c. All right, so whoops, we better pop that in. I moved my c. C is x minus 1, x minus 2. So when I'm looking for a constant, I will also get c times -1 times -2, which is 2c. Whoops. All right, so I'm going to get a -2, and the e, so the +16 here, and that's going to give me 2c. So I'm going to get 14 is 2c. So c is 7. Alright, so now putting all that together. It's difficult when you can't see it all, but we will try. Alright, so we're integrating ax squared, and a is 1, so x squared dx. We're integrating bx, d is 7. Sorry, c is 7. And my pen is struggling. So, as usual, you're used to this, we're just filling it in. So let's give it a go. So this will be x cubed on 3. This will be 3x squared on 2. Then we've got 7x. We've got a log. We've got another log. And of course a plus c.